Good day, everyone. This is Joe Tutors. Welcome, everyone. Kindly take a seat as we'll journey again in our resistivity log journey. We've done about the qualitative interpretation, and today we're going to do the quantitative interpretation. What does that mean? Quantitative just means that what you need to do some calculation, some machine learning, and all of that. Okay, to be able to estimate some characteristics of your reservoir. Okay, so yeah, quantitative just tell us about okay, you know data of the content without calculating. Quantitative means you are calculating. You have to do some numerical formulas. You have to do some formulas, and we need to interpret very well. So for today, we're going to look at our logs. So the same thing that we did in our gamma log, we are going to be to look at our skill. You know, I told you that the first thing about quantitative is that in your skill, you should to know your skill. Are you with me? You need to know your skill. This is your skill here. You need to know your skill. So now we are moving from 0.2 to what? 2000. Are you seeing that? From 0.2 to what? 2000. Okay. So clearly we must know how to split our what? Our skill. So now for your I need to focus here. Okay. Let's bring your mind to this side. Can you see here? You have 0.2 here. You have 0.2 here. Okay. You have 2000 in this side. 0.2, 2000. Okay, good. So now you find out that you have faint lines, then thick lines, faint lines, thick lines, faint lines, thick lines. Well, that's not really the focus. Okay, so the way to read it is that you're going to be having, so starting from a new one, you know this 0.2, 2000. So everything is like as if you're having 2 times 10 raised power n, where your n is increasing like as if you have a number line. Okay, so we have, if you have -1 here, you have what? 0, have you? Here be 1, here be 2, here be 3, like that, like that, like that. So 2 times 10 raised power n, which means the next reading in logarithm, you know, logarithm is times 10 raised power something. So the next reading in your logarithm will just be, so the first one is 2 times 10, 0.2 is what? 2 times 10 raised power what? -1, have you? Then the next one will be what? 2 times 10 raised power what? 0. Can you see? Next one got 2 times 10 raised power what? 1. Next one got 2 times 10 raised power what? 2. Then the last one, which is at 2000, which is what? Times 10 raised power what? 3. Okay. So first note those ones down first. Okay, your check lines. So this guy here is what? 2. Have you? 10 raised power 0 is 1. 1 times 2, 2. Next one is what? 2 times 10 raised power what? 1. So 20, 0.2 to 20. Like if you are doing times 10, the easy approach is that you can actually ignore this and just do times 10 times 10 times 10 times 10 and you reach the last one. Okay. The next start line is what? 200. Then you have a what? 1000. Okay. So nice. We know how to interpret between the next intervals, the next big intervals. Then after that, because we are doing a log, that's why our intervals like this, because it's a log. Okay, and you know in your log, each moving from one scale to another, it's not like as if you are doing linear scale where you're having 1 and 2, where everything is still linear. No, if you are done with your linear, you are moving to the next logarithm increase. Okay, which is times 10. Okay, so linearly we're going to be increased in between 0.2 and 2. We count linearly. We count linearly. We count linearly. We count linearly. Okay, so let's look at it again. So this 0.2 is 2 having. So let's count linearly. So here the next one, we're going to be increasing by this 0.2, this 2. So we count just the values and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here we have 10 of it. So which means since we have 10 vertical lines, so we know that at the end of the day we're going to be increasing by what? 0.1. So linearly you're improving by that. Okay, so next one is 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. Okay, we have 1 here. Can you see that? Then 2. Then you start again. Use two again. So you have 3, 4, 5, 6, 7, 8, 9, 10. Okay. Then you have, can you see here? 30, 40, 50, 60, like that. Then you see 100. Then you count 300, 400, 500, 600, 700, 800, 100, 1000, then 2000. Okay. Yeah, it might be kind of confusing. So, but let me just go a brief again over it again. So, the way you're just improving it, very kind of easy. So, you have 0.2 here, you have 2. So, you are just increasing. You know that what is here is 10 raised per minus 1, have you? In the increase, have you? This is your log. That's why I started with your log. 10 raised per minus 1, that's the increase here. 2 times 10 raised per minus 1, have you? That's what represents 0.2. 2 times 10 raised per minus 1. What's 10 raised per minus 1? That is 1 over 10, and that's 0.1. So which means that linearly you should be moving by what? 0.1. So 0.1 will be what? 0.3 here, 0.4, 0.5, 0.6, like that, till you get to what? 1. Okay? You get to 1. So you've gotten to 1, and you know that the next thing is 2 again. So the next thing that is 2. What does 2 represent? 2 is what? 10 raised by what? 0. What is 10 raised by 1? 0. That's what? 10 raised by 0 is what? 1. So you come here, start increasing by 1. So here will be 3, 4, 5, 6, 7, 8, 9. Okay? Then we have 10. Remember that the next starting of reading your log again is what? 20. Okay? So, and 20 is what? 2 times 10 raised by what? 1. So, which means you are increasing in your linear by what? By 10 raised by 1. What is 10 raised by 1? That's 10, abi? So, next one is what? 30. Can you see? So, I see adding plus 10. 40, like that, it's 200. If it is 200 now, you are starting from, you are reading from. 200 is what? 2 times 10 raised by what? 200 is what? 2 times 10 raised by what? 2. What is 10 raised by 2? 10 raised by 2 is what? 100. So in 200, let's say this is your 200 now. So in between it, before you reach 2000, you'll be increasing by what? 100. So you have what? 300, 400, 500, 600, 700, like that, like that. Yeah. So that's why you should first start with what? Noticing your what? Your log difference 0.22. Mark those things down. Then you know that in between, you're just moving by what? By the intervals of your log, determined by your log. Okay, that's why I started with your 2 times 10 raised per n. So if it's not 2 times 10 raised per n, if it's even 10 raised per n increase, probably what you have here is 0.1. Okay, that means the next set of reading should be starting from 1. Okay, yes, tick line. Start from 1. The next tick reading is what? 100. Okay, the next one is what? 1000. So now between 0.1 to 1, you'll be counting by what? You'll be increasing by what? 0.1. Between 1 to 100, you're increasing. Oh, sorry, yes, supposed to be 10. Yes, supposed to be 100. Forgive me. So 1, here with 2, 3, 4, 5, 6, like that. 8, 9, 10. Good. So that's how we count. We move linearly. Okay, we move linearly. Immediately we entered into under new scale. Okay, so if you are doing 0.1, 0.1, 0.1, immediately enter a number that is not is in the tens of 10 raised per. That's this thing you count again. Okay, so in our qualitative analysis, still be a long ride. So we know how to count our scale, we know how to move our scale. So first question first is, so our first question. Okay, so we're giving that to so there's some resistivity that we find in our stuff. We have R naught, RW, and RT. Okay, so R naught is our resistivity okay, of the formation that is fully saturated with water, fully or completely saturated, fully saturated with water, with water. Okay, so RW is just resistivity of water in the formation. So it's not, might not be in a region where it's completely saturated. So just RW. And RT is what? The true resistivity of the formation. The true resistivity of the formation. True resistivity of the formation. So depending on where you are, okay? So yeah. Now the first question is determination. Determination of RW using the range of RW using RWA, okay, method, RWA method. Okay, so how do we find RW using what? RWA what? Method. Okay, so the first thing to note is that what? Um, so the first thing, you want to solve this question. So you say you find RW, okay, the resistivity of water, okay. You need to find, you need to look for it what? The first thing is that what? You look for where we have the cleanest sand. Look for where we have the cleanest sand. Look for where we have the cleanest sand. Okay. Then you will correlate. You what? Correlate it to the resistivity log. You correlate it to what? To the resistivity what? Log. Look for where we have the cleanest sand. Then you what? Correlate it to what? To the resistivity log. Okay. Good. Now, let's start by finding our RW, okay, our activity. Okay, so this is my good. So let's get back to our log. This is actually very long, right? Okay, let's go back to our log. And in our log, you can see very well that your log having. So at what point we have the lowest, the cleanest sand, the clean sand, the cleanest, the cleanest sand, the cleanest sand, the cleanest sand is where we have the lowest API, okay, in our reservoir. Okay, so we're talking about reservoir now. So if I'm saying clean sand, it cannot talk about which log talks about sand or shale. Where is the mind going to? Gamma log. So you must, like, we use all logs together. So if we look at it now, we saw that this place in our reservoir, okay, this place is one that shoots more. Okay, so I come here, can you see? So you just really can you see? To cut, can you see? This is where we have lowest salary. Oh, my son is not as sharp. At this line here, where it cut it. Okay. So what I'm clearly saying is that you correlate where you have your, this is our this thing. Okay. This is your gamma, have you? And your stuff look like this. Okay, let's say you have something like this, for example. Okay, so you now discover that here, let me do like this back. Okay, let's cover that here is what? Your clean sand. So if here is where you have the lowest lowest API, this is your gamma API, lowest API, then you correlate it to what? To your resistivity logging. Okay, that reading. Then you now read it upward. You have a scale. You get that reading upward. You get the scale upward. Okay, you correlate it. At what point? is it on my scale that this line cut? Okay, at what point that my previous step. So this point here is now your reading. Okay, that's your what? Arrow knot. Okay, so you come here. Can you see that? You come here and you read it off. So when we have it here, so we discover that at this point here, that's it. Cut it. Okay, like 3 lines here. Have it? Yeah, have it? Good. At this point here. So remember that here is 2, right? Here is 0.2. Here is 2. 2, 3, 4, 5, 6, 7. Can you see that? So that's why. So here at this point here is our what? 7. Okay, that's why for you to know you know how to read your skill. So we got that what? So our formula, I didn't write that earlier, so forgive me, is that RT is equal to what? FRW. So, but anytime we are solving for clean, we look for resistivity in cleanest sand, okay, our R naught is always equals to what? Our RT. So that's how we get our R naught, okay? So this R naught is equals to RT in this scenario, FRW. So we now say that what? R naught that we got is what? 7 what? Ohm meter, abi? Good. So we now say RT is now what? 7 ohm meter. Good. Now, the next thing is to look for what? Your formation factor. Abi? We've gotten this in our equation. We're looking for this guy, but we need to find formation factor. What's our formation factor formula? Our formation factor formula is F is equals to A over neutron density what? Log. Okay? Or what? All square. A over our porosity, okay, of neutron density combined. All what? Square. So from this, what do? We just a normal is just 1. Okay, let's go to m. We take a as 1 normally, so we just do 1 over what? This guy all square and d. So in our calculation, we just substitute our formula as rt is equals to 1 over what? Porosity, neutron porosity log times what? Rw. Okay, good. And we can just cross multiply because this is RT is equals to RW over ND. Okay, so when you cross multiply, get that what? RW will now be what? RT times what? Porosity, neutron density porosity log all what? Square. So we've come to the end of our resistivity log interpretation. So I can't talk about neutron density log now. So in the next video, we're going to see how to solve our neutron density log. But just take note of this: when you get your neutron density log all square, you are good. You will solve this question. Very, very simple. Okay, thank you for joining with me as we went through a lot of things, went through how to check your skill because very important. You can see that if you don't know how to read very well, read your skill intervals very well, you won't be able to get your R naught, which will you use to get your what? Your RW. Thank you very much for listening. Kindly ensure you subscribe to my video.